I just completed refurbishing this Marconi Atalanta marine receiver, and just completed the realignment process today, full IF and RF alignment, and I'm coming to check the IF response curves. I realized I couldn't actually use the signal and spectrum analyzer I'd normally use, because the tracking generator in that only goes down to 100 kilohertz, and the second IF of the Atalanta is 85 kilohertz. So I couldn't check it out using my normal method. So instead I've rigged up what I used to use, which is an HP H601A sweep generator. That's combined with HP H600A digital marker generator. This is also operating right at the lower extreme of its capability. The H601A really only goes down to about 100 kilohertz, but you can actually force it down below that to maybe about 50 kilohertz. But it gets very sort of flaky around there, especially when you try and sweep it. We're on symmetrical sweep at the moment, centered on 85 kilohertz. And the output of the sweep generator is connected to the grid of the first mixer tube, to that green capacitor. And the swept output is connected to the X axis of this Tech 604 monitor, and the Y axis of that monitor is connected to the detector tube of the receiver. The detector tube is actually a dual diode, so it's on one half of that diode at the moment. It's a balanced detector. It's a times 10 scope probe going into an isolation capacitor, and that goes straight into the Y input of the monitor. And you can see there the response. Hopefully, I'll try and speed it up a little bit. Switch the light off, so you should be able to see it a little bit better. You can hear it on the receiver as well, as it sweeps through the passband. As I speed it up, it actually affects the shape of the response curve, unfortunately. On the widest setting at the moment. Switch it to the intermediate setting. So if you can see, the shape of the curve has changed. Unfortunately, this tech monitor is kind of, the tube's on its way out. It's okay in low light conditions, but on a video I'm not sure it'll come out too well. Anyway, that's the intermediate bandwidth. Just adjust the frequency to get it back in the center of the passband. Now we're on the narrow setting. Increase the amplitude a little bit. Hopefully that's coming out on the video. Now when you go to the narrowest passband, very narrow, it actually distorts the curve at this sort of sweep speed. If you slow the sweep speed right down, you can see a more realistic shape to the curve. But it's ringing at the top of it, and you've got a longer decay time on there, which isn't really representative of what the actual shape is. It's a very narrow response on this particular setting. But really, all I wanted to do was to get an idea that the passband looked okay. It's sort of not a quantifiable method really, unless I switch the markers in on the generator. But I don't think that'll work too well in this setup at these frequencies. So I really just wanted to check the symmetry of the curve, and it looks pretty symmetrical as far as I can tell. Back on the widest setting now. There we go. Just some final checks on the Atalanta before it goes back to its owner. I think I will be changing out the volume control on the receiver. It's a little bit flaky at the lower end, which I think means I have to take the front panel off. So that's a job for tomorrow, I think.